Hello everyone. Welcome to Datamful. I hope everyone has downloaded the dataset. Let us begin our project. As always, we will begin our project with importing necessary packages. Some of the packages you already know, like pandas, NumPy, matplotlib, sklearn, and nltk. Some new packages are also present which we will learn when we use them later in the project. Next step is reading the data using pandas. Read the CSV file training variance, and store it in variable data_variance. After that, we will see simple information of data which we have already seen in the previous video. Like shape of the dataset, it consists of 3,321 data points or individual values. And the number of features equals to 4 in training variance. The 4 features we have is ID, gene, variation, and class. You can get the head of the data set is shown. Let us understand these features in more details. We already have overview of these features. The very first feature is ID, the id of the row used to link the mutation to the clinical evidence. The second feature, gene, is the gene where this genetic mutation is located. The third feature, variation, is the amino acids change for these mutations. The last feature, class, is 1 to 9, the class these genetic mutation has been classified to. After reading training variance, our next step is reading the text data again using pandas. Now, get the shape of this data also. You can see, this data set also has 3,321 data points, same as our training variance. It consists of 2 features. First is ID. Second is text literature - which is previous research texts, which have been already done by doctors in the field of cancer diagnosis. In the previous project, we have already seen when there are text feature we have to perform pre-processing. For that is I have defined a function NLP pre-processing, which will perform these steps on the total text. That are removing stop words - that is words like the, is, are, so, etc., which gives no weightage to text when using in machine learning, therefore they are removed. The second step is removing special char as shown here with space. In the third step, we replace multiple spaces with single space. In the last step, we have converted all the characters into lowercase. Also, if the word is not a stop word, then retain that word from the data. These pre-processing steps, we have already discussed in our previous project also. The code for these pre-processing steps are very easy, one-line code as shown. I don't think anyone will face any difficulty in understanding them. Next, we will check if there are any missing values or not. For doing this we use a for loop, for every index row in our data text. And if the type of row is string NBSP, we perform the NLP pre-processing function which we have defined above. And else if there is no text description found, for it we will simply print it. Also, we will print the time taken to perform pre-processing. This is not a mandatory step, but if you want to check the time taken for the code to run, you can use this function, time.clock, which will return the time to run the code. We can see that for several IDs, there is no text description for ID as present. And it takes 184.64 seconds to complete the pre-processing for our text feature. The time taken will be dependent on the system you are using. After this, our next step is we have to merge both our training variance and training text, as our objective is we have to classify these genes variation with respect to text literature into one of the 1 to 9 classes. To merge both gene variation and text literature, again we will use pandas.merge, data variance and data text NBSP, on ID. This means that we are merging on the basis of ID. After that, when we get the head of our dataset, we can see both the dataset have been combined. Our next step is we will find if any null value is present or not. We can see that there are several data points where the text is missing. So where the text literature is missing, we just use the gene and variation feature combined and place them in text feature just for simplicity. Now when you check for missing data points, you will not find any missing data points. So far, we have done the pre-processing, check for null values, and also fix the empty values. So our data is ready to be used. After this, our next step is we split the data into train, test and cross-validation. Now first let us understand why we split the data in test, train, and cross-validation. The train and test split will be clear to you why we do it. We first train our model with the training data set, and after the model is trained we test our model with the test data we have talked about with a very simple example of a kid identifying the apple. We first train the kid by showing him different fruits along with apple, and teaching him the difference between apple and other things. And once the kid is trained, he is ready to identify the apple correctly. The same way our machine learning algorithms behave like a kid brain, we first have to train the model. When the model is trained we take the test of our model using test data. So you must be wondering what is the need of cross-validation then, when the work can be done simply by train and test split of data. There must be some problem in the simple train-test split. That is why we have introduced a new term, cross-validation. But what is that problem? The problem is overfitting. It will make sense pretty soon, I promise. Just bear with me. Let us consider that we are designing a machine learning model. A model is said to be a good machine learning model if it generalizes any new input data from the problem domain in a correct way. This helps us to make predictions in the future data that data model has never seen. Now, suppose we want to check how well our machine learning model learns and generalizes to the new data. For that, we have overfitting and underfitting, which are majorly responsible for the poor performances of the machine learning algorithms. Let us first understand underfitting. A machine learning algorithm is said to have underfitting when it cannot capture the underlying trend of the data. It's just like trying to fit undersized pants. Underfitting destroys the accuracy of our machine learning model. Its occurrence simply means that our model or the algorithm does not fit the data well enough. Whereas in overfitting, when we train it with a lot of data, just like fitting ourselves in oversized pants, when a model gets trained with so much data, it starts learning from the noise and inaccurate data entries in our dataset. Then the model does not categorize the data correctly, because of too many details and noise. As you can see here, that overfit models classify both the cross and circle perfectly, but the problem is to classify them perfectly it have overworked and also consider the noise, due to which the performance of algorithm drops. The underfit model as shown here has underworked as many of the points are classified wrongly, therefore this model will also show poor performance. So what is the appropriate fitting? It is the fitting where we can achieve a smooth curve which classifies most of the point correctly, even there are outliers or noise classified, even then it is fine. Now how to overcome these errors, and decide the perfect fit for the algorithm. So to avoid overfitting we perform cross-validation. It is very similar to the train/test split, but it is applied to more subset. Meaning, we split our data into k subsets, and train on k1 of those subset. What we do is to hold the last subset for test. One of the methods on cross-validation is k-folds cross-validation. In k-folds cross-validation we split our data into k different subsets. And then we use each fold subsets to train our data and leave the last fold as test data. We then average the model against each of the folds and finalize our model. After that, we test it against the test data. Cross-validation allows you to tune hyperparameters with only your original training set. So what cross-validation does, it decides the right hyperparameter to choose for your model. Now, what is this hyperparameter? Don't worry about this term now, we will learn it later for sure, but for now, just understand hyperparameter is a parameter whose value is set before the learning process begins. Hyperparameter is a term which is responsible for model getting overfit or underfit. If we choose the right hyperparameter we can get the perfect fit. We will study about hyperparameter in much more detailed in the later section. So I hope you understand these concepts. Thank you very much for watching this video. Like, share and subscribe to the channel.